Assalamu alaikum warahmatullahi wabarakatuh. Welcome to the pre-lab 9 of EE237 Electric Circuit Lab. We are going to explain common source MOSFET amplifier. We are going to build this circuit into simulation platforms in Multisim and in Tinkercad. So first we are going to take this circuit to Multisim and build it and get these value. After that we are going to implement it using Tinkercad as a simulation using breadboard. So let's start first with Multisim. So I have took screenshots from the circuit and we are going to build it. First insert the components. We have AC voltage source. After that we have resistor. And we have capacitor. And note that it is capacitor polarized. We have from the source we are going to get VDD, which is a source for DC. It is fixed 10 volt like a battery. Also we have the transistor. Note that the transistor that the MOSFET transistor that we are going to use, this one, 2N7000. I'm going to look for it. 2N70. So that's it. Get the ground, put it, and the circuit is ready to go right now. So let's start. I'm going to connect the circuit, but first you have to make the configuration. For the first capacitor it is polarized and the positive terminal is to the right, so I flipped it. Also we have another resistor upside here. Another capacitor here. Resistor and resistor up there. So now let's connect the circuit. Here the capacitor has 3 terminals. First one is called D, drain. Second one is source. Third one is gate. So now I have connected the drain and the source is connected to the ground and the gate is connected to the polarized positive terminal of the capacitor. After that this is connected to a resistor, and here we have the second leg of the resistor is connected to the first terminal of the power source, which is AC, and close the circuit to the ground. It's down. After that we have here the resistor is connected like this. And from the right side connect the capacitor, but you have to rotate it first. The positive terminal now is connected towards the transistor, Note that here the polarity is positive towards the transistor and the polarity is positive towards the transistor. After that, connect the resistor and the other terminal, close the circuit connected to the ground. So let's start configuring the values. First, VDD is 10 volt. Here the source is 100 millivolt V peak to peak, which means that it 50 millivolt peak only with 10 kilohertz as a frequency. So let's put this 50 millivolt and 10 kilohertz as frequency. After that we have 10 kilo ohm, 22 microfarad, 1 mega ohm, 22 micro, 5.6 kilo. Last one is 10 kilo ohm. And that's it. Let's get our Tektronix oscilloscope from the right, connect the ground, and we have here 3 things to measure. First channel is going to the input. Second channel is going to this point, which is between the resistor RS and C1, the capacitor. So put it here in between. Third one is connected to V output, which is between the second capacitor C2 and RL, which is here. And now let's run the simulation and open the Tektronix oscilloscope. You have to open channel 2 and channel 3, enlarge voltage pair division for all of them in order to properly see the signal. You could also vary the position in order to check clearly the values of the signals. And right now you are ready to get measure button, and for channel 1 get V peak to peak, and same for channel 2, get V peak to peak, and make the third one for channel 3 and write these values here on this table. V source for the V source, VS2 which is at channel 2, which is this point, the point between RS and C1, which is this point, and for V output is channel 3, which is between C2 and RL. And that's the values in this table. Put screenshot from the multisim for your circuit and for the output from Tektronix oscilloscope, and go to the second part, which is Tinkercad. So there is a website called Tinkercad. You have to look for it, create an account, it's free. After that you will find this page, click create circuit and open it. We are going to build the same circuit but using the breadboard. So get a breadboard and let's start building the circuit. So you have to focus with me and follow the instructions well in order to facilitate your next lab inshallah. So let's start by getting the components. First, get function generator. Get the oscilloscope. And also get the power supply. And now look for the components, resistor, that's it. Capacitor, we need polarized one. Search for it. Capacitor polarized. And here look for the MOSFET N1. So like what I have said, there are three legs: drain, gate, and source. So let's now connect the circuit. We are going to start with this, which is the transistor. It is N channel. So first let's connect this circuit. After that, we are going to implement the rest. So let's start. We have here on the middle, we have the transistor. So let's put it into the breadboard. Okay. Note that this one is the drain, which is here. Middle one is gate, which is there. And last one is the source, which is down connected to the ground. So let's connect first from upward. We have here the function generator. We have here the oscilloscope, and here we have the power supply. The power supply, we are going to put 10 volt, which is this, and get the positive terminal connected to here, anywhere. And we have here 10 volt is connected to 5.6 kilo ohm resistor. So get this resistor rotated. Now the positive is connected to the first terminal here. We are going to connect from the second terminal to the drain. This is the drain. So I am getting a wire from here to the drain. And the source is connected to the ground. So this is the source. I am going to put it on the ground. And here, of course, to close the circuit, the negative is connected to the same ground. Okay, so this is the first drain and source. The third one is gate. Gate is connected to a resistor. Look for here, there is a wire connected to a resistor 1 mega, and it is connected to the drain. So gate and drain are connected together by a resistor. So I am going to copy this resistor and I am going to put it into any place. We noticed that here this point is the drain and this one is the gate. So this is a drain. So get a wire here, and the gate is the middle one. So get a wire and put it there. I'm going to change the color. We have implemented the first part. Let's go to the second part, which is on the left. Let's connect these things with another color. So first I have V source. put V source, for example, here in this point, and V source is connected to a resistor which is 10K. So copying this resistor and put it here and change it to 10 kilo ohm. And do not forget to change these values. This one was 1 mega ohm, and this one, which was here, 5.6 kilo ohm. After that, this is connected to a capacitor, but from the negative side, and the positive side is connected to the gate. Okay, so let's get this capacitor. It is polarized, so make sure this is the negative. Negative is connected to 10 kilo ohm, and the positive is connected to 1 mega and the gate. So get a wire. Where is the gate? This is the gate, the middle one. So put it on the middle one. That's it. We have connected the right side. Let's go and connect. We have connected the left side. Let's go to the right side. We are left with a capacitor and a resistor. So I'm going to copy this one and put it on the other side. Get another color. Here is the negative, but we need the positive, so I am going to flip it. So it has become positive right now. The positive is connected to the drain. Okay, where is the drain? This is the drain. On the same line, I'm getting a wire from the positive to the drain. And the negative is connected to a resistor, so I'm going to copy the 10 kilo ohm resistor, which is this. Copy it. I have put the negative connected with the first leg, which is this, and here the other leg is connected to the ground. So get a wire from here, put it to the common ground. Okay, and do not leave negative disconnected. You have to connect it to the negative, which is common ground also. And your circuit now is complete. Okay, here we have oscilloscope. So first I'm going to connect the negative here on the negative, and the positive one time I am going to connect it to VS. After that I am going to connect it on VS to measure VS2, which is between RS and C1, and the third time is to connect it from between C2 to RL. So for example, I'm going to connect it between C2 and RL, which is this area, this line between the capacitor and RL. So it is on this line, so put it here. And that's it. I need for this experiment is to take a screenshot for the circuit from the Tinkercad and put it onto your lab report, and do not forget to save it. I'm going to rename it here MOSFET Lab, and you have to share it. So after you save it, go to click here on Tinker, look for the circuit, which is this. Okay, get the setting, go to properties, change it from private to share link, or make it public, save changes, and copy the link. You have to change the setting first in order for me to view your circuit, and put the link here into link for Tinkercad and the screenshot below. That's it for pre-lab 9. See you next experiment, inshallah.